We'll continue now by discussing power distribution, specifically location and clearances for power distribution. Let's start by talking about how power distribution equipment is required to be marked. Obviously, the equipment needs to be marked, and the requirements for marking of power distribution equipment is found in Article 110.3. These particular pieces of equipment are required to be listed or labeled and installed per their listing or their labeling. Project inspectors need to be sure to review and verify that the amperage and voltage ratings meet the minimum requirements for the project and also match the submittal information that was provided by the design team / contractors. Additionally, where equipment may be serviced, maintained, examined, or adjusted while it is energized, arc flash warnings are required to be applied to the equipment. The details for these arc flash warning markings are included in Article 110.16, and these markings may be factory or field applied. Whenever equipment markings are field applied, the caution, warning, or the danger signs or labels that are field applied must adequately warn with words, colors, or symbols. They're required to be permanently affixed and not handwritten. They are also required to be durable, and the requirements are identified in California Electrical Code Article 110.21b. An example of a simple equipment warning sign that can be field applied is shown on the right hand side, where they're actually showing words and symbols and obviously identifying that there is danger and high voltage. One note to remember is that ANSI 535.4 provides specific guidelines for the design and also the durability of safety signs and labels for application to electrical components. During a project inspector's review of materials delivered to the job sites, and specifically for power distribution cabinets, etc., it's important that the project inspector verifies that the cabinet itself has an approved rating for the environment that it's going to be installed in. Table 110.28, which is called the Enclosure Selection Table, provides details relating to enclosures, specifically relating to their approved use both indoors and outdoors. Project inspectors must verify that the ratings are suitable for the location, generally indoors and outdoors, and additional information is also provided in Article 110.11. The National Electrical Manufacturers Association, also known as NEMA, provides ratings that are specific to installation environmental protection that is required for the equipment. And the different criteria for protection of the equipment are dust, drip, rain, and water tightness, or rain proof. Obviously, these particular environmental protections are going to be determined and approved by the design team, and it's extremely important that the project inspector inspects the installation of these components based on the information that was provided by the design team in the approved plans. Let's talk now about panel identification. On the left of this slide, you'll see an excerpt from a plan set that actually shows a panel schedule. And this particular panel schedule identifies the details for panel KD1A, Section 1. And we have a blow-up of a small portion of this panel identification schedule. on the right hand side, and you can see that it shows some very simple parameters for the panel itself, such as the size is 225 amps, the voltage for the panel is 120/208 volts, it's 3-phase, 4-wire, the main is an MLO main, and the breaker AIC rating, which is ampere interrupting capacity rating, is 10,000 amps. Now it's important to understand that the ampere interrupting capacity actually describes the maximum fault current that a protective device, a circuit breaker or a fuse, etc., can clear safely without actually welding closed or causing damage to the equipment or to personnel. So we're going to see this AIC rating very frequently throughout this presentation, and you're certainly going to be wanting to pay particular attention to this number when you're reviewing materials that are being used on the job site. To continue, it's got a copper bus and a standard neutral. And again, these are just a few of the very important pieces of information that you're going to find on a panel schedule on the blueprints. Let's continue now talking about power distribution, specifically working clearances that are required to be provided for personnel to facilitate their maintenance and service of power distribution panels. Now it's important to not confuse the working space requirements with the equipment space requirements, and let's clarify those here. The working space is intended to protect personnel. This is a space, minimum space, that is provided in front of all distribution panels or electrical panels that allows personnel that is working on the panel to work in the area safely to protect their personal safety. Equipment space, which we'll talk about at the end of this section, is intended to protect the equipment. So it's very important to make that distinction. This information is also included in Article 110.26. Now, equipment that is greater than or equal to 1200 amps and is also greater than 6 feet wide requires one door, which is going to be understood to be the entrance or the egress at each end of the workspace. Now, there are exceptions to this, and you can review these exceptions in Article 110.26b2. However, again, with most issues relating to electrical construction, the electrical engineer and the design team are going to do their homework. They're going to verify that whatever is approved by them for installation on the project is actually safe and compliant with the code. So understand that even though we're addressing some issues that you would construe as being primarily design issues, the information that we're providing and the generalized understanding that we're attempting to reiterate is extremely important for a project inspector to obtain and maintain just a broad knowledge of the basis for the decisions that are made by the electrical engineers for the design that is being constructed. Now, with respect to, again, high-powered equipment, exceeding 1200 amps, the doors must open, the egress and entrance doors to the area, again, must open in the direction of egress. They also must be equipped with a listed panic hardware, and dependent on the equipment ampere rating and the distance from the door to the equipment, the working space itself may vary. And again, this is going to be determined, verified, and documented on the approved plans by the design professional. So again, I can't stress this enough that it is so important that project inspectors inspect per the plans, primarily for electrical construction. Let's continue now and discuss some of the details with respect to the minimum working spaces that are required around power distribution equipment. With respect to the minimum working depth that is required in front of panels, you can refer to Table 110.26A1 and Article 110.26A1. And there are basically three voltage ranges that we're concerned with that actually determine the parameters for safe minimum working spaces. And those three voltage ranges are 0 to 150 volts, 151 to 600 volts, and 601 to 1000 volts. Now there are basically three conditions that are identified in the California Electrical Code, which also dictate the minimum working spaces that are required in front of equipment. Condition 1 is a condition where you have exposed live parts on one side of the room and no live or grounded parts on the other side of the room. And in these conditions, condition 1, 3 feet minimum clearance depth is required. Now this applies for all voltage ranges from 0 to 1000 volts in condition number 1. Now condition number 2 is defined as an area where there are exposed live parts on one side of the room and grounded parts on the other side. Grounded parts meaning concrete, brick, or tile walls, for instance. Those are considered grounded. In these conditions, condition number 2, either 3 feet depth, 3 foot 6 inches in depth, or 4 foot minimum depth clearance is required. Condition 3 is a condition where you have exposed live parts on both sides of the room. And again, dependent on some other parameters that we'll discuss in the next slide, either 3 feet minimum depth, 4 feet minimum depth, or 5 feet minimum clearance depth will be required. Continuing with the minimum working space, the width of the working space in front of power distribution panels and electrical panels is identified in Article 110.26A2. And the width of the working space in front of the electrical equipment must be at least equal to the width of the equipment or 30 inches, whichever is greater. The working width must also allow 90-degree minimum opening of equipment doors and panels. The height or the minimum height of the working space in front of these power distribution panels must be equal to the height of the equipment or 6 foot 6 inches minimum above finished floor, grade, or platform, whichever is greater. And it's important to understand also that there's a slight allowance made in this minimum working height area, and that is that other electrical equipment that is associated with the electrical installation, either above or below the equipment, is permitted to extend 6 inches maximum beyond the front of the equipment. This sketch right here is an attempt to try and visualize or provide a visual representation very simply of the different conditions that we just discussed and also the dimensions that we also discussed. And as you can see by looking at this, there's a 30-inch minimum width, a 6 foot 6-inch minimum height requirement, and depending on which condition it is, either 36 inches, 42 inches, or 48 inches in depth is generally required. Now this would cover most of the scenarios that we see. There is a possibility that a 5-foot minimum clearance depth is required when condition 3 exists for voltage ranges between 601 and 1000 volts. Now throughout this presentation, I'd like to make it perfectly clear to project inspectors that anytime you see an image that looks like it came from a blueprint, that you should be thinking in your mind the phrase that we had shared earlier in the presentation, which is read and review every word and every symbol on every plan and specification sheet for every project every time. This is so important. We cannot stress this enough, how important this simple tactic or this simple protocol is. Now, with respect to this particular sketch, all we're really showing here is a plan view of an electrical room, which is next to a mechanical room. And we're basically showing here a depiction of what we just got through discussing with respect to minimum working space depths, where if you see here, this particular service panel identified as MDSKD is a situation where you have an energized piece of equipment on one side of the room and a grounded area on the other side of the room, therefore requiring between 36 and 48 inches minimum clearance, again dependent on what the energized situation is in the panel. It's important to note that some other options are certainly permitted for designers based on the equipment ampere rating and door layouts. So again, we want to stress this. It's extremely important that project inspectors inspect construction based on the plans. These two photographs depict a couple of examples of improper working space provided in front of distribution panels. On the photograph on the left, you can see that we're basically reiterating that the clear depth required in front of a panel is generally 36 inches to 48 inches. And also, the required minimum working width in front of a panel is 30 inches. Now the problem that you can see in this particular photo is that that small gutter on the bottom near where a serviceman's foot would be or feet would be, that looks like it's connected to a transformer, certainly extends out further than 6 inches in front of the panel. So that's what makes that an improper working space. If you look at the image on the right hand side, we have something very similar, where we have a panel mounted to the wall, and as you can see, there's a giant piece of conduit coming from the left in front of the panel and below the panel, and then swoops down out further in front of the panel, hits an LB, and then shoots into what appears to be, again, maybe a transformer. Obviously, we've got the same situation happening here that makes this improper, that this conduit and the LB actually extends out further than the permitted 6 inches in front of the face of the panel itself. So be aware of these types of non-compliant conditions. These two images also show another example of an improper working space. And the image on the right is basically showing a simple panel, an empty panel box with some conduits run to the top. and the project inspector is pulling his tape on this space that is in front of the panel. And as we recall, the minimum required working space width in front of any panel is 30 inches. Now what we're depicting on the left-hand side is a blow-up view of the tape measure showing that the actual working space width is only around 29.5 or 29 3/8 inches. Now it's unfortunate because you would say, well, it's pretty close is close, right? Nope, close is not close ever when you're talking about minimum required working spaces in front of dangerous energized equipment. So obviously this is non-compliant. Luckily or fortunately, the project inspector was able to identify this at the very onset of this installation. I don't know the details about what was shown on the plans, whether there was a mathematical bust in the dimensions of the room, who knows. The end result is this. This particular panel had to be moved. There's no question about it. You could look at it similar to a lot of accessibility elements where all you have to do at the end, anyone can pull a tape measure. Anyone can check to see if this thing is compliant or not forever after installation. So it behooves everyone that proper inspections are done, especially relating to clearances since they relate to public safety, and that these particular types of issues are identified and rectified as soon as possible, which would negatively or which would have the least impact negatively on the schedule, the budget, the scope of work, etc. Now we're going to talk a little bit about service equipment. For service equipment that is less than or equal to 1,000 volts, this particular equipment must be marked to identify it as suitable for use as service equipment. This is identified in Articles 230.66 and 408.4. These must be listed or field labeled, and to clarify, field labeling is basically a safety review that is performed by a third-party electric equipment evaluator or inspector. So this is a process that is acceptable for in the California Electrical Code for the labeling of electrical equipment. So it basically carries the same weight as listing a piece of equipment from the manufacturer. I've rarely seen this in my life, but it is permitted, and it's important that project inspectors understand that this is a permissible method for identifying service equipment. The service disconnecting means must be provided to disconnect all conductors in a building or structure from all service entrance conductors. Okay? Now, these service disconnecting means must be readily accessible. And what does that mean? It means that you can access it immediately. It does not require the opening of any doors or panels or the use of any tools. These service disconnects on these pieces of service equipment will be readily noticeable, readily accessible. You'll be able to see these disconnects on the face of the panels themselves, and this is extremely important. This information is included in Article 230.70 of the California Electrical Code. Another thing that project inspectors are going to have to review for compliance is to make sure that any ground fault protection that is required for equipment is provided and is also performance tested as required. These requirements are detailed in Articles 230.95, 215.10, and 240.13. But remember, ground fault protection of fire pumps is not required. And that's pretty obvious. Since fire pumps are an emergency piece of equipment, they are not permitted to be on a ground fault protected circuit, or a circuit that is protected by a ground fault protector. They're treated completely differently since they are part of the emergency fire suppression system. We're going to talk just a little bit about service equipment, primarily switchboard nameplates, and we have a simple quiz here. If you were to look at both of these labels, they're almost identical, okay? And the question that we're going to ask is, can these both be used for service equipment? And I know it's a little bit difficult to read the information on these two labels, and I apologize for that. However, if you're to look very closely, you can see the one on the left here has some verbiage right in the middle in the comments section. And this is what identifies that this particular panel or switchboard can be used as service equipment. And what it says is, suitable only for use as service equipment. Maximum of 6 disconnects. And again, the point for this little quiz is to just make sure that project inspectors are reviewing the use and the appropriateness and the approval for any type of service equipment based on labeling that is provided by the manufacturer and the approved plans. This photograph shows an interesting situation that all project inspectors and contractors, for that matter, should be extremely concerned about and also aware of. And that is that even during construction, the required working clearances must be maintained. And as you can see, if you look carefully in this picture, on the left-hand side, you can see that there's a job box where the corner is sticking out. And obviously, this job box is directly in front of this switchgear or this service equipment. And it does not appear that the minimum working clearance has been provided. Additionally, there's another article in the California Electrical Code, which is Article 110.26b, which also stipulates that required working spaces must not be used as storage. So it's important that you're aware of this and also keep an eye out for this in construction, during construction, and remind the contractors of how important it is for the safety of their personnel working on this equipment that the required working spaces are maintained during construction. The picture on the right of this slide is provided primarily as sort of a scare tactic, but not really. Personally, whenever I see an open panel like this with no dead front attached, and I'm able to look at all of those dangerous pieces of copper in the back, those conductors, which ordinarily would conduct energized electrons, it just concerns me. And the purpose again for this is to make sure that project inspectors understand that their personal safety is of the utmost importance to the division of the state architect, as well as the school district and design team members and other members of the construction team. This is a very dangerous situation, and again, we're not presuming that this particular panel is energized, but the thing to take from this is respect the fact that these are very dangerous areas, and you, as well as all of the contractors and people in these areas, need to always respect the fact that these can be very potentially dangerous, and you should always view any of these panels, switchboards, equipment, conductors, anything that is utilizing electricity as potentially dangerous. And also, of course, we've identified here that in Article 408.3A2, that service equipment is required to have barriers between the service bus bars and the remainder of the board. This slide is devoted to the topic of dedicated equipment space, which, as we identified at the beginning of this presentation, is separate and distinct from dedicated working space. So dedicated equipment space is identified in the California Electrical Code, Article 110.26 E1A. And it is basically defined as a space equal to the width and depth of the equipment, extending from the floor to the lower of 6 feet above the equipment or the panel, or to the structural ceiling, must be dedicated to equipment. And there's also a stipulation that suspended ceilings are not structural and are permitted within the 6-foot space above the panel or the equipment. Foreign systems, such as plumbing and mechanical, etc., are not permitted in this dedicated equipment space. But there is an exception, of course, in the California Exception Code. Foreign systems are permitted, provided protection is installed to avoid any damage to the equipment or the panel from condensation, leaks, or breaks in the foreign system itself. And this direction is located in Article 110.26 E1B. And I was just joking by calling the California Electrical Code the California Exception Code. However, there is a little bit of frustration in my voice in that I have always attempted to try and memorize some things that were obvious. However, as numerous exceptions and numerous changes have been made to the California Electrical Code and other codes, obviously, it gives me a sense of frustration from an inspection perspective that there are just so many exceptions to almost every rule that it just makes our lives and certainly your lives as project inspectors a little bit more challenging in keeping up with the code, since you always have to review for exceptions.